Imagine looking up one night and discovering a planet the size of Neptune drifting through interstellar space. Just a dark world moving silently through the galaxy. Now imagine astronomers confirming that one of these rogue planets is passing through our region of the Milky Way right now. Not crashing into Earth, but close enough to raise a question. Could something like that ever threaten our solar system?
Unlike Earth, which is orbiting the Sun, there are billions of rogue planets roaming the Milky Way, not bound to any host star. One of them has been spotted on the edge of our solar system. What if this interstellar object swung through it? How would this space invader affect the orbits of the planets? Could it possibly push Earth out of the habitable zone?
It doesn't orbit a star. It doesn't follow a predictable solar path. It moves alone, a dark, frozen world drifting through interstellar space. And according to new observations, one of these rogue planets is passing through our cosmic neighborhood. So the question practically asks itself, should we be worried? First, let's define what we're talking about. A rogue planet, sometimes called a free-floating planet, is a planetary mass object that doesn't orbit a star. It may have formed around a star and been violently ejected by gravitational chaos. Or it may have formed independently from collapsing gas clouds, like a failed star. Either way, it wanders the galaxy untethered. Astronomers have detected several candidate rogue planets in recent years, especially using data from the James Webb Space Telescope and large ground-based surveys. Because these worlds don't shine with reflected starlight, they're incredibly hard to see. Most are detected via infrared heat signatures or gravitational microlensing, when their gravity briefly bends the light of a background star. And that's exactly how many of them are found. They reveal themselves not by glowing brightly, but by distorting the light behind them. Recently, researchers confirmed a rogue planetary mass object moving through the outer region of the Milky Way. Early orbital modeling shows it's not bound to any nearby star. It's just passing through. Now here's the critical part. Passing through does not mean heading straight for Earth. Space is incomprehensibly vast. Even when objects enter our broader galactic neighborhood, the distances involved are enormous. The odds of a rogue planet directly colliding with Earth are so small they're effectively zero on human timescales. But could it disrupt the solar system gravitationally? That's a more interesting question. Let's talk scale. Our solar system is dominated by the Sun's gravity. Even massive planets like Jupiter, the most massive planet we have, only slightly perturb planetary orbits over long periods. For a rogue planet to meaningfully disrupt Earth's orbit, it would need to pass extremely close. Not just within a few billion kilometers, but close on astronomical standards. Closer than Pluto, possibly within the outer Kuiper belt. So far, there's no evidence of that happening. The detected rogue planet appears to be passing at a distance measured in trillions of kilometers. That's interstellar near, not solar system near. There's a big difference. Rogue planets are thought to be common. Some estimates suggest there may be billions of them in our galaxy, possibly even more rogue planets than stars. Many form in young star systems and get flung out during chaotic gravitational interactions. When massive planets like Jupiter migrate inward or outward during early system formation, smaller bodies can be ejected entirely. It's cosmic pinball. Over billions of years, these orphaned planets wander through the galaxy. Occasionally, one passes through another star system. Most of the time, nothing happens. But could something happen? In theory, yes. If a rogue planet passed through the outer Oort cloud, the distant shell of icy objects surrounding our solar system, it could gravitationally disturb comets. That might increase the number of long-period comets entering the inner solar system thousands or even millions of years later. This wouldn't be immediate chaos. It would be subtle, delayed, and statistically small. There's no indication the current rogue planet is passing close enough to cause even that level of disturbance. It's simply too far away. Another concern people often raise is visibility. Could we even see a rogue planet coming? That depends on its size and temperature. Young rogue planets may still emit faint infrared radiation from leftover formation heat. Older ones are cold and dark, potentially only a few degrees above absolute zero. Detecting those requires sensitive infrared instruments. That's why observatories like JWST and upcoming wide-field infrared missions are so important. They expand our ability to spot faint, wandering objects long before they approach anything significant. Right now, there is no known rogue planet on a collision course with Earth, and astronomers track near-Earth objects constantly. Organizations such as NASA's Planetary Defense Coordination Office monitor asteroids and comets that pose potential risks. A rogue planet large enough to threaten Earth would not go unnoticed. It would gravitationally affect outer planets long before reaching us. Its influence would be measurable decades or centuries in advance. We would see the perturbations. We don't. So why does this story sound dramatic? Because rogue planets capture imagination. A dark world drifting silently toward our sun sounds like science fiction. It evokes images of sudden gravitational chaos, frozen alien landscapes, or hidden cosmic threats. But reality is calmer. Astronomy deals in probabilities and distances, and space is mostly empty. To put things in perspective, the nearest star system, Alpha Centauri, is over 4 light-years away. That's about 40 trillion kilometers. Even a rogue planet passing near us would still likely be trillions of kilometers distant. In human terms, that's not close. That's practically untouchable. However, scientifically, rogue planets are fascinating for other reasons. Some may have thick hydrogen atmospheres that trap geothermal heat. Theoretical models suggest that under the right conditions, subsurface oceans could exist on rogue planets, even without a star. Life without sunlight. It's speculative, but intriguing. These drifting worlds may represent hidden laboratories for planetary science. They tell us about system formation, about gravitational instability, about how chaotic young solar systems can be. Every rogue planet discovered helps refine those models. The current object being studied appears to be roughly planetary mass, possibly similar to Neptune or smaller. It was identified through subtle gravitational lensing effects and infrared signatures. It is not accelerating toward us. It is not entering the inner solar system. It is simply passing through our region of the Milky Way, as countless objects have before. Our sun itself moves through the galaxy at about 828,000 kilometers per hour. The entire solar system is orbiting the center of the Milky Way. Everything is drifting relative to everything else. Sometimes paths cross, but crossing in galactic terms rarely means collision. So should we worry? No. There is no credible evidence of an impending planetary threat. What we should feel instead is curiosity, because rogue planets remind us how dynamic the galaxy truly is. Star systems form. They evolve. They eject members. They interact gravitationally across vast distances. The night sky looks peaceful. It isn't static. Somewhere out there, this lone planet continues its silent journey, untethered to any sun. It may wander for billions of years. It may one day be captured by another star's gravity, or it may drift forever between systems, unseen and untouched. For now, it's just a data point, an object detected, a trajectory mapped, a mystery studied, not a threat. And perhaps the most reassuring part of this entire story is simple. If something truly dangerous were heading toward Earth, we wouldn't find out from a rumor. We'd see it in the math. And right now, the math says we're safe.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.